Hey, what is up, everyone? I hope all of you are doing great. And today, right now, I have about 245 subscribers, and I want to thank all of you for supporting me. And today, I thought of installing Instagram after about 1 year, and what I saw is that everyone's happy faces and everyone's flashy lifestyle. So I got depressed and I deleted Instagram and I started watching Hera Fairy. Man, I need to rethink about my life. Anyways, so let us start with our SHM lecture series, and today I'll be discussing about a question in the beginning which came in JEE Mains 2021, 26th February, second shift. The question was that a particle is performing SHM and it starts from its mean position. That means at t equals to 0, x is 0. Okay. Time period is t, and the question was find the time taken to complete 5/8 of the oscillation. Okay, 5/8 of the oscillation. Now, according to the question, there may be some discrepancies because a student might think that 5/8 of the oscillation means if you divide the oscillation according to the time period like that, or if you divide the oscillation according to its displacement. Okay, I guess NTA have divided the whole oscillation according to the displacement. I mean, if this is x equals 0, this is x equals a, this is x equals minus a, so NTA have thought of dividing the whole motion like this. Starts from here to here, 2, 3, 4, 5, 6, 7 and 8. So basically the question here, it is asking 5/8 of the oscillation. So 5/8 means 1/2 plus 1/8. Okay, so we have divided the whole oscillation in 8 parts, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so half of the oscillation means here to here, half of the oscillation, and 1/8, that means here to here. So time taken to reach the particle to this point via this path. So if you use a phasor diagram to calculate this result, the answer would look something like this. So this one is a/2, actually minus a/2. So let us take minus a/2 here. So this angle must be pi/6, this one is pi, so the whole angle is pi plus pi/6, that is 7 pi/6, and this angle, because the particle starts from here, and this angle is covered by an angular velocity of omega, which is constant, that is 2 pi/t times small t. So final answer is 7t/12. Okay, now if you divide the motion according to the time period, that means from this time is t/4, so t/8, t/8, like that, the answer would be different. The answer would be 5t/8, but this one was the answer key given by NTA. Anyways, NTA should be more descriptive about their question because this creates a confusion in students' mind in the examination hall, but hey, who cares about the student? Anyways, sorry, jokes apart. So let us continue with our lecture. Today we will be discussing about the energy equations. Okay, energy equations in SHM. So this would be a very quick video, and energy equations in SHM, actually I teach this thing in work power energy chapter in the section of conservative forces. As we know, a particle performing SHM, this kind of force acts on that particle. Okay, and this is basically a conservative force. Okay, conservative force, because as you can see that the force is a function of x only, and if you write in vector form it would look something like this. Anyways, now every conservative force is associated with a potential energy. Potential energy. Now if you recap the motion of the particle, at some instant, if the particle is at a displacement x and having a velocity v, it might be in the positive direction or the negative direction, that doesn't matter. First let us find out the potential energy related with the particle at this instant. So how do I find potential energy? We know that du equals minus f dx, that is change in potential energy equals to negative work done by the conservative force. So here the conservative force is minus kx, that is kx dx. Okay, so this is du. So change in potential energy equals to negative work done by the conservative force yields this one. So if you integrate in both sides, when x equals to 0, that means when the particle is in its mean position, there might be some initial potential energy, okay, which we will call the reference potential energy. At displacement x, let the potential energy be u. So u minus u naught gives you half kx square. Fine. So potential energy as a function of x becomes u naught plus half kx square. Okay. In 99% of the cases, or in most of the cases, people consider u naught as 0, which gives you a more simpler relation of potential energy. So as you know, every conservative force is related with some, is mapped with some potential energy function. So for spring force, that is F equals minus kx, the potential energy is half kx square. Fine. Now let us check the kinetic energy. So kinetic energy is very simple. Kinetic energy of a particle would be half mv square, and we already know that v equals omega square times a square minus x square. So you can just put that equation here. So we get half m omega square a square minus x square. This we already learned in the previous lecture. Now let us just summarize all the things that we have studied right now. That suppose a particle is performing SHM, this is the mean position, this is a, this is minus a. At any time t, if the displacement of the particle is x, velocity is v. Okay, we know that the general relation of x is a sine omega t plus phi. I am not repeating all these things. So velocity will be del x del t, that would give you a omega cos omega t plus phi. Fine. So potential energy as a function of x is u naught plus half kx square, that would give you u naught plus half k x matlab a square sine square omega t plus phi. Very nice. And the kinetic energy as a function of x would be half m v square, that is half m omega square a square times cos square omega t plus phi. And we already know that omega square a square is nothing but, that m into omega square is nothing but half k a square cos square omega t plus phi. Now for right now, let us take u naught as 0. Fine. So if you find the total mechanical energy, you would at any instant x, you would write ux plus kx, that would give you half k a square, okay, which is a constant. Of course it should be a constant, because we have already said that there would be no damping force, there will be no frictional force when we will be studying about SHM, okay, and that constant force is half k a square. If you recall my previous lecture, I have already said for studying SHM we need to first fix the total energy of the system, so that we can fix the amplitude of the motion. So here you can see that if you fix the energy, if you fix the total energy of the system, you are actually fixing the amplitude. So this is the relation of the total energy and the amplitude. Okay, so again, if you recap the whole thing, it is u naught plus half k a square, sorry, sine square omega t plus phi, considering u naught as 0. So maximum potential energy is nothing but half k a square, because the maximum value of sine square omega t is 1. Similarly, for kinetic energy, as a function of x, it is half m or half k a square cos square omega t plus phi. So the same thing, maximum value of kinetic energy is also half k a square, which is both equal to the total energy. So basically total energy remains fixed. So the total energy is basically getting distributed between potential and kinetic. So if you draw the graph of potential energy and the kinetic energy on the same coordinate system, kinetic energy, potential energy is parabolic, that is half k x square. What the hell, sorry, something like this. And the kinetic energy would look something like this. Okay, just check the equation. Fine. And the total energy would be this one. Okay, so basically this whole thing would lie between minus a to plus a, because it is a bounded system. Okay, at any instant, if you point out okay, this one is the potential energy, this one is the kinetic energy graph. At any instant or at any position, if you calculate the kinetic and the potential energy, their sum would yield you the total energy, which is a constant. Okay, as you can see, for some given value of x, kinetic and potential energy are equal. So let us see, we have kinetic energy as half m omega square a square minus x square, and potential energy as half m omega square x square. So half m omega square gets cancelled out. A square equals 2x square, x equals plus minus a by root 2. So at minus a by root 2 and plus a by root 2, the total so the energy, kinetic energy and the potential energy are equal. Fine. Okay, so these were some basic things, and we need to know how to write the total energy of a particle performing SHM at any situation, because in further lectures you will see that while finding out the time period or the frequency of natural oscillation, energy relations makes the problem very simpler. Okay, for example, I am telling you, now suppose that there is a system. Okay, there is a spring block system. Okay, this one is k, this one is mg. As you can see, there is some initial stretching of the spring, let that be x naught. Okay, and if I pull this mass by some amount and release it at some instant of time, this one is basically the mean position. At some instant of time, the block would be here, making a displacement x. It will have some velocity v, of course. Let me take this as zero potential energy situation. So at this instant, if I try to write the total energy of this spring block system, okay, it would be total energy means kinetic energy plus spring potential energy, that is half k x naught plus x square, and the gravitational potential energy, that is mgx, because this one is the reference line and this is below the reference line, so minus half minus mgx. Now as you know that total energy will be constant for a particle performing SHM, so just differentiate with respect to time, you get mv dv dt, that is the acceleration basically, kx naught plus x dx dt, that is velocity, minus mg, v equals 0. Okay, so v gets cancelled out, ma plus k x naught plus x minus mg equals 0. Now in equilibrium situation, when the spring was initially stretched, mg was acting downwards, kx naught was acting upwards, so kx naught equals mg is the equation for equilibrium situation. So this one gets cancelled out, we have ma equals minus kx, so a equals minus k by mx. So this is our omega square, time period is 2 pi root over m by k. Simple thing, but I am just demonstrating that how energy equations can be used to find out the differential equation or equation of motion of a particle, and further we can also find out the time period or frequency. One more thing I can tell here for this question, that as you can see, when I am placing the whole mass or placing the whole spring block system in a vertical manner, there is always a constant force mg acting on the mass. Okay, but this mg is just replacing the mean position. That means if I keep this whole system in a horizontal manner, the mean position would be the natural length of the spring. Okay, but in this case the mean position is not the natural length, the spring is initially stretched by some amount mg by k. Okay, but that does not hamper the time period of the situation of the system. Okay, for small oscillation, time period in this situation and in this situation remains same. So basically constant force on a mass or on the mass does not change the time period or frequency or angular frequency. Okay, so if I ask you that there is an inclined plane, there is a block, if I attach a spring k m, this is theta, there is always a constant force acting mg sine theta here, that would just displace the mass by some amount, shifting its mean position, but the time period would be the same as it would have been in horizontal condition, 2 pi root over m by k. Okay, you just need to remember, saves a lot of time. Okay, now actually in SHM finding out the time period is the only thing that is the most difficult section of SHM. Using energy equations is just a tool that we will be using to find out time period. Sometimes people ask from in JEE people ask from energy relations also, but that part we have already studied in work per energy section. Okay, so okay, till now I have already completed most of the theory required to start solving problem. From next class I will be focusing on numericals mostly, mainly on previous year questions and few more questions that would be helpful for you for your upcoming exams. Okay, so if you like this video and if you want me to continue this lecture series, please do subscribe, like the video, and I hope you all get into your favorite IIT. Okay, so peace.